What's up guys, this is LeetCode 138, copy list with a random pointer. A linked list is given such that each node contains an additional random pointer which could point to any node in the list or no. Return a DP copy of the list. The linked list is represented in the input-output as a list of n nodes. Each node is represented as a pair of vol random index, where vol is an integer representing node.vol, random index, the index of the node, range 0 to n-1, where random pointer points to or null if it does not point to any node. Okay, so a linked list with a random pointer, and we have to create a DP copy. So a DP copy is just another list containing exactly the same values, not exactly the same nodes, but the same values in the same structure to the linked list given as an input. So yes, one thing that we have to pay attention here is everything is a node. So the current node is a node, the next pointer is a node, the random pointer is a node. So that's one thing that we have in common here for all the data is just nodes. And I think we can use these nodes to point or to find something that we will create. As we have to do a DP copy, we have to create all the nodes again using the values of the nodes of the current linked list. Yeah, so I think we can use the current node to map to a new node. By doing that, we can traverse this linked list, and for every node we find, we can just get the node that we created and just point to the next node and to the random node, because we already mapped all the nodes of this linked list. Yes, I think by explaining it seems to be a little bit confusing, but we can try to write a little bit of code and see how this works. So yes, let's try to write some code. Yes, as I said before, we can do something like this. So imagine in this example here we have a node 7. We can map this node to a new node that we are gonna create. So a new node 7. And we can do this to the 13 and the 11. So 13, 11, and by doing that, we have a map of the original node mapping to a new node with the same value. And now we can set the pointers. Like, how can I get this new node here? I can get it by something like map of 7, because map of 7 will give me the value of this new node. And if I have this new node, I can just set the next pointer to let me see, to the map of 7.next, because 7.next will give me also a pointer that exists in this hash map, and it could not exist. So we have to check before if the node.next exists, because if it is null, we don't need to execute this line of code. And we can do this also for the random pointer. and will be like the same. We just have to get the random pointer here. Yeah, so I think this could be a solution. So we first need to traverse the entire linked list to populate the hash map. And after that, we just need to set the next pointer in the random pointer, because as I said, everything in this linked list are nodes. The next pointer are a node, the random pointer are a node. So the random pointer is a node and the next pointer is a node. Yeah, so let's try to code the solution. We can start by checking if the input is valid. So if head is null, we can just return null. And we can declare our hash map. New dictionary will be a dictionary of node and node. And now we can start to traverse this linked list. And I think we will need to declare a dummy head here, because I don't want to change the value of this head node, because we will use it again in, I think, in the next iteration. So yes, let's try to declare a dummy head here with the value of head. And to traverse this, we will check while dummy head is not null. So map dot add head and new node of head.vol, as we did before in the example. And here it's not head, it's dummy head, and dummy head is equals to dummy head dot next. Okay, so this will populate the hash map for us, and after that we will set again dummy head to head, and now we have to iterate through these, yes, to dummy head again, to the linked list again, because we need now set the next and the random pointers. So again, while dummy head is not null, we can start to set the pointers. So map. Remember that I said that if the dummy head dot next or if the dummy head dot random is null, we don't need to execute this line. We don't need to execute the setter. So if dummy head dot next is different of null, so map of dummy head dot next is equals to map of dummy head dot next. Yes, that's it. And also for the random pointer, dummy head dot random. Here's the random. And yes, we also have to check for if the random pointer is not null. If dummy head dot random is not null, we can execute this line. So let's check this again. We are populating our hash map. We are setting head. We are setting dummy head to head again. We are traversing the linked list. We actually have to set dummy head to dummy head dot next. And here we are setting the next pointer of our value of new node to the next pointer, and also the random pointer to the new random pointer. Yeah, so After that, we can just return the head node of the new linked list, which we can find into our hash map by getting the key of head. Yeah, so if we do not have any typo here, I think this is the solution. So let's try to run the code. Random with lowercase. Run again. Wrong answer. So here is right, here is wrong. So let's see where we did something wrong. So map add dummy head here is wrong. It's not head.vol, it's dummy head.vol. So let's see this again. Output 777. So as you can see, we were putting here the head. So all the values we add into the hash map are the value of the head node, which is 7. So let's try to run again. Yes, let's try to hit submit. Yes, that's it. So time complexity here is big O of n. Even with traversing the linked list twice, first one here and second one here, we are doing this in a flat way. We are not doing this in a chaining way. They are not doing like one iteration inside the other iteration. And this is why it's big O of n, where n is the number of nodes in the linked list. And the memory complexity is also big O of n, where n is the length of the linked list because we are calculating a hash map here with all the nodes of the linked list. So that's it, guys. Thanks for watching.